Hello guys, welcome to the channel. Today we will discuss multiple linear regression. So what is multiple linear regression? Multiple linear regression is an extension of linear regression where instead of one independent variable means instead of one input column we will have multiple features means multiple input columns to predict the target y means to predict the output column. So we saw in the previous video where I performed simple linear regression where I had one input column and one output column. Output column will be one in every case, but I had also only one input column, right? So see, on this data set today we will perform multiple linear regression. Okay, so these are the two input columns. Okay, these are the two input columns. On the basis of these two input columns, we are predicting our output column, that is salary, total experience and total certifications. By total experience and total certifications, I am predicting the employee's salary. Okay, so you can see here we have multiple input columns. We can have four, five, six input columns also, but in this case I am taking only two input columns, okay, for performing multiple linear regression, right? So we can see by plotting a 3D graph for multiple linear regression. So you can see here x1, x2, and y. X1 and x2 are the two input features, okay, input columns. Suppose in this case, total experience will be my x1, certifications will be my x2, okay, and y will be my output column. In this case, I have salary column as y. This is my output column y, and every data point is a salary. Every data point here is a salary on the basis of total experience and total certifications. I have explained it in this notes by taking of example of house price prediction. Suppose X1 has a feature size and X2 feature has the second feature which is bedrooms. And on Y, it's my output. What is my house price? And every data point is my house price with these two input features, right? So on the same way, we have here two input columns. On the basis of two input columns, this and this, I am predicting my output column. So how we can basically build a machine learning model using this data set using multiple linear nets. Okay, so I will show you. So for basically coding purpose, we will use Jupyter Lab. Please download Anaconda Navigator to to perform to build machine learning models in Jupyter Lab. So in my system, it is already downloaded. So just search here after downloading Anaconda Navigator, Anaconda prompt. Okay, Anaconda prompt. Write CD. Give your file location here. Give your file location. Control V. Press enter. Write Jupyter Lab. Again press enter. It will navigate my Jupyter Lab into my browser. We will wait for a few seconds. I will choose this. I will rename this. I will rename this multiple. Okay. Now I will import some required libraries. Okay. Import Matplotlib dot pyplot as plt. Import Seaborn as SMS. Okay. Now I will load my data set. Okay. Suppose I'm taking a variable data to load my data set. pt.load slash csv as because I have CSV file. Right click, copy path, control V. Now check my data is loaded or not by checking first three rows. Yeah, my data gets loaded and here are its first three rows. Now I will check is there any null value in my data set. We can check that. Okay, there is no null value in my data set. Okay, so this is fine. Now I will first show you by plotting a heat map that data, I'm taking data as data's correlation, okay, and not is equal to true plt.show. Now you can see total experience column is nearly one. So it is very important column for my output column salary, total experience. Certifications. Certifications is not too much beneficial for my salary column, but yeah, I will take certifications also because I have to show you the multiple linear regression. So it should have more than one input columns in it. So now first I will divide my data set into X and Y, right? X and Y. And in X, I will take my all input columns, which are total experience and certifications. And in my Y column, Y variable, I will take my salary column as output column. Okay. X is equal to, I will use iLog. I will use iLog minus 1. So what we are doing here? So I'm saying in my X variable, give me the whole data set of all, give me all rows. This means all rows. And this means give me all columns also, but minus one. Minus one means leave the last column. Last column is my output column. So leave this column and give me all in all columns and all rows. Okay. So this is what the meaning of X is equal to data.ilog is. Now I got my all input columns in X. Now I will take in Y my output column. Okay, what is my output column? Salary. Okay, now now I will split the data set into training data and testing data. Suppose I will split my data set into 80% for training data and 20% for the testing data, right? How we can do that? From Scikit-learn dot model selection import train test split. Okay, Shift plus enter. Now I'll give all four variables x train, x test, y train, and y test. Okay, is equal to, I will call my train test split. Okay, now what are my two variables in for input and output column x and y? Now I have to convert my data set into 80% training and 20% for testing. So how much we are taking for testing? We are taking 20%. So I will write test size is equal to 0.2. Okay, I have already discussed the train test split in my previous video. In our previous video. Okay, so random state is equal to 42. Okay, now my data gets splitted. Now I will build my machine learning model for this data set. Okay, now from sklearn dot linear model import linear regression. Okay, okay, okay. This is the spelling mistake. Sorry for that. Okay, now I will give an object to call my linear regression. Suppose I will take LR is equal to linear. I have made an object. Okay. Now I will fit my X test and Y test. Okay. Sorry, X train and Y train for my linear regression model. Okay. I will fit that. How we can fit that? LR dot fit. I am training the model by X train and Y train. Okay. X train means training data of these two input columns, and Y train means training data of this output column. Okay, so I am training the model by giving X train and Y train. Okay, so it's get fitted. Okay, my model get trained. Okay, now I will check the accuracy of my model, how much accuracy I'm getting for my model. LR dot score X test comma Y test, right? Plus enter. So we are getting a accuracy of nearly 90%. Just multiply by 100. Yeah, we are getting accuracy of almost 90%, which is a very good accuracy, right? We can improve my accuracy also. But yeah, this is also a good accuracy for my model. Okay. Now we will check by predicting a value. Okay. Suppose I will take this input 7 and 1 for predicting salary. Okay. So LR dot predict what are my values? 7 and 1. I will give 7 and 1 as my input. Okay. Now see here. It gave me 79,139. Okay, so here it was 77,318 was my actual, and it gave me 79,100. So it is nearly close. Okay, so it is giving not perfectly, but yeah, it is quite accurate, right? Because also it has 90% accuracy. So this is how we can perform multiple linear regression. Okay, so that's all in this video. In the next video, we will discuss polynomial regression. Okay, thank you.